Very good morning, dear students. Welcome to the session on applications of trigonometry. Let us start the session with few general knowledge questions. Yes, here is the Mount Everest. Do you know the height of the Mount Everest? Yes, it is 8,848 meter. Okay, and here is the Angel Waterfalls. What is the height of this Angel Waterfall? Yes, it is 3,230 feet. Okay. What is the distance between the earth and the sun? It is 150 million kilometer. Okay. How are these heights and distances measured? That is with the help of applications of trigonometry. Yes, with the help of application of trigonometry, one can find out the heights and distances. Yes, let us go back to the origin of the trigonometry. It is a story of a king who wants to build a pyramid. He wants to construct a pyramid that is taller than Cheops pyramid, because the tallest pyramid built so far was the Cheops pyramid, and he wants to build a pyramid which is taller than that, and he wants to know how high the Cheops pyramid was. He asked that question and everybody was not answerable. He said, "You are the wisest man in the kingdom. I am sure you will figure out a way to measure the height of the pyramid in just 2 days of time." Everybody said, "No, no, it is impossible. It's not possible." But there was one person called Thales, right? He said, "It is possible, my dear Hujur. It is possible, my dear king." And he took 2 days of time and he started observing the length of the shadow as the sun, the position changes. So I want you to observe. See how when the sun's position is changing, the length of the shadow also changes. Suddenly he got an idea. Yes, at some point of time, the length of the shadow must be equal to the height of the pyramid. At that time, if I measure the length of the shadow, then I get the height of the pyramid. So he used one stick. So this is the height of that stick length is equal to the height of the person. Okay, and he placed it like this. Now the length of the shadow is not equal to the length of the stick, correct? Now he wants to find out at what time the length of the shadow is equal to length of the stick. Yes, this is the time where the length of the shadow is equal to length of the stick. And at this time, if you measure the length of the shadow, that is equal to height of the pyramid. Yes, he will measure the length of the shadow and he will get the height of the pyramid. Okay, and he get the prize from the king. Okay, now this is the story, a beautiful story came to an end. Now let us analyze this story. So here at particular time, the length of the shadow is equal to the height of the pyramid. What is that time? What is that time where the length of the shadow is equal to height of the pyramid? What should be the angle? That is theta here I have represented. What should be the angle of inclination of the sun with respect to the earth's horizontal? Do you have any idea? Yes. Anyhow, this is 90 degree, correct? One angle is 90 degree. The sum of the three angles of a triangle is 180 degree. That means 180 minus 90 is 90. Right? And here we know that this AB is equal to BC. That means the angles opposite to these equal sides AB and BC must be equal. The sum should be equal to 90 and the two angles A and C must be equal. That means each angle must measure 45 degree. Correct? So that means this theta is equal to 45 degree. The sun ray is making an angle of 45 degree with the earth's horizontal. So this is called angle of inclination, or in another words we call altitude of the sun. Now altitude of the sun is 45 degree. So when is it possible? Somewhere around 9:30 to 10 o'clock range, we will find the length of the shadow that is equal to height of the pyramid. Okay. Now see here, as the angle of inclination changes, you can see the length of the shadow is also changing. Here it is not equal to the height. Understood? So this is the height and this is the length of the shadow, and yes, this is the distance and this is the acute angle. Yes, as the angle changes, you can see the length of the shadow is also changing. That means there should be some definite relation between the length of the sides of this right angle triangle with respect to this acute angle. That relation we are going to learn in this lesson, trigonometry. Tri means it is three, gono means side or angle, metry means measurement. That means we are discussing about the relation between the acute angle with respect to the length of the sides of the right angle triangle. Okay, so you have studied many relations, and all those trigonometric ratios are like this. So in this, yes, I'll draw one right angle triangle here. This is the theta, and this is the opposite side, and this is the adjacent side, and this is the hypotenuse. Okay, so sin theta is equal to opposite side divided by hypotenuse. Cos theta is equal to adjacent side divided by hypotenuse as another trigonometric ratio. Tan theta is equal to opposite side divided by adjacent side. And the inverse of all these trigonometric ratios are cosec theta, sec theta and cot theta. Just exactly the inverse. Okay. Now you have learnt all these trigonometric ratios, and there is an easy way to remember all these trigonometric ratios by one statement called so ka tova. How do we remember this? So ka tova. Just like a Chinese language. So SOH, sin theta, opposite hypotenuse. Okay. Ka, cos theta, adjacent side and hypotenuse. Tova, tan theta, opposite and adjacent side. I hope you remember. Then you remember the opposite ratios of these trigonometric ratios. Okay, fine children. Now here is the situation where you want to measure the height of the tower, and you are watching the top of the tower at an angle of 60 degree, and you are standing at a distance of 15 meter from the foot of the tower. So what should be the height of the tower is the question. Now if this angle was 45 degree, then this distance is equal to the height. At that time it could have been 15 meter. Understood? But now the angle of inclination is 60 degree. The sun's altitude is 60 degree. Yes, how do you find the height? Now we will just use our knowledge of trigonometric ratio, that is connecting the opposite and adjacent with respect to the given angle. That is opposite to adjacent is tan theta, and here theta is 60 degree. If you know the value of tan 60, then only you can solve this particular problem. If you know the value of tan 60, then you can find out the height, that is AC. Not only that children, in some places you will be given this height. Okay, you will be given this height and this angle, you will be asked to find this hypotenuse. Understood? So there are various situations where you should know the measurement of the angle for a particular trigonometric ratio, and you have studied all those angles in the form of an activity. You can remember all the values of the trigonometric ratios with the help of an activity. Yes, see here, I am going to show you these 5 fingers are nothing but the 5 standard angles: 0, 30, 45, 60, 90 degree. Yes, now right side cos theta and left side sin theta. Remember this. Okay, and square root symbol. You should have a square root symbol, and divided by 2 is common. Okay, now we have the standard angles here, and we have sin theta and cos theta. If you remember these only sin theta, then cos theta will come automatically, and tan theta, and all are trigonometric ratios. So sin 0 degree. Now the thumb finger that is indicating 0 degree is folded. Left side, how many fingers are there? Left of this folded finger, how many fingers are there here? There are no fingers. Number of fingers are 0. So what is square root of 0? It is 0. Divided by 2 is nothing but 0. Hence sin 0 is 0. Okay. So I write sin 0, 0. Now what is cos 0? As I said, right side, the number of fingers you find out to get the cos value of 0 degree. How many fingers are there? That is 4 fingers. Correct? 4 fingers. What is square root of 4? That is equal to 2. Divided by 2, always that is equal to 1. That means cos 0 is equal to 1. Now shall we find 30 degree? Sin 30 degree, you fold 30 degree finger. Sin 30 degree is equal to. Now how many fingers are there to the left side? That is sin 30. Only 1 finger is there. Square root of 1 is 1 divided by 2. That is 1 by 2. Okay. Now right side, how many fingers are there? 3 fingers are there. So that is cos 30. Cos 30. Right side 3 fingers. Square root of 3 is root 3 divided by 2. So root 3 by 2. How easy. Yes. And remember, sin 45 and cos 45, the values are 1 by root 2 and 1 by root 2. Both are same. Okay. Yes. Now sin 60. Sin 60. 3 fingers. Root 3 by 2. Cos 60. That is 1 by 2. Okay. Similarly, sin 90 and cos 90, that is 1 and 0, you can find out. Understood? Yes. Now we have understood that if this value angle was known and this distance was known, then we can find out the height of the tower. Understood? But how to find this angle? 60 degree. How to find? Not only 60 degree, it may be any angle, some standard angle, say 45, 60, 30 degree. How to find out that angle? You need some instrument. Correct? Yes. Today we are going to learn to make an instrument so that it can measure you this angle of inclination. That is called as inclinometer. Okay. So using that inclinometer, okay, you can find out the measurement of this angle, and you will set that for a particular standard angle, and then you can find out the height of the tower. Okay. Yes. How we can find out? Just see here. Suppose say it's 60 degree, you have set 15 meter. Tan 60 is equal to AC by BC. That is tan 60 root 3 value. Root 3 is equal to AC by 15. AC is equal to 15 root 3. 15 into root 3. Root 3 value is 1.7. You multiply 15 with 1.7, approximately you will get the height of the tower. Now, as I told you, who will give you this angle of inclination? So we should measure that. Correct? Yes, this one you can measure somehow, but how to measure this? As I told you, we have an instrument called inclinometer, and here is the procedure to make an inclinometer. We suggest you to make this inclinometer and present to your teacher. Okay, and all of you will become mathematician to measure the height of your school building and the height of the platform or the height of any nearby tree. Yes, making use of inclinometer. So what is that you do? On a piece of cartridge sheet, place your protractor and draw a semicircle like this. Okay, and mark the angles. So starting point is 0 here. It's not 90 degree, it is 0. And right side, yes, we have 10 to 90 degree. Left side we have 10 to 90 degree. Okay, yes. Now remove the protractor. Color half of the part with red and another half of the part with blue of this semicircle. Okay, now remove the protractor, mark the angles as shown. Yes, cut out, take the cutout of this. Yes, now you have to use one drinking straw so that you can find out the height of the tower. You find out an object with to the height of the tower using the straw. This is observer. Okay, fix it. Okay, yes. Now next, take a fine thread, fix one end of the thread at O, tie a pointed heavy object as a plumb line on the other end of the thread so that it will be always resting at 0. Okay, now fix the wooden strip on the piece of plywood as shown as a stand. Okay, yes, now your inclinometer is ready. Okay, now using this inclinometer you can see, check the angle of elevation. The angle in the red region will be showing you the angle of elevation. Okay, when you are waving the bottom of an object, then the blue part of the angle will helps you, that is angle of depression. Okay, now see here how to use. Yes, he is going to find out the height of the school building. Yes, he is using inclinometer. He is setting that inclinometer angle for exactly some angle, known standard angle, 60 degree, 30 degree, 45 degree, any angle. 45 degree means no need to worry because length of the shadow is equal to height of the object. But now here you need some standard angle, and yes, you can find out the length of the shadow, and then knowing the length of the shadow and the angle of inclination, you can find out the height of the school building. Okay, take this as a project, children, and I want you to do this and show to your teacher and write the procedure how you did, what is the logic behind this. Okay, so I wish you all the best, children. Thank you.